paying attention to on any of your phylogenies, you would never have to include them, okay? But I just want you to know that we have fossils of other things that would belong to these groups. And so here's where the evolution of jaws happens right here. And so we have bunches of things that we call stracoderms, but if we tried to resolve their phylogeny, we'd have a bunch of new branches, a bunch of new names. And so I'm not going to do that because we don't have, all these are extinct. Somewhere out of these stracoderm lineages that went extinct arose the lampreys. Okay, they're the only remaining critter that's similar to a stracoderm. Further down, we have a hagfish. Okay, so these are not vertebrates. Here's where we have vertebrata. So then, a similar case with the evolution of jaws, with the macrostomes. We have some early forms here that are paraphyletic. They all went extinct, but out of them, at least one branch survived. Okay, and so I'm not going to put a bunch of names in here. So it's just going to be macrostomes, and then we have two branches of Nephrostomatum, okay, namely the Chondrichthyes and Osteichthyes, okay? So that, but on an exam, you do need to know what stracoderms are. You do need to know what placoderms are, but they should never be included in any phylogeny. I would never have them there, okay? Because there's a lot of fossil history. I'm going to put in some fossil history over here, but we have fossils galore that we'd have to put into the phylogenies, and that would really muddy up the waters. All right, so Chondrichthyes, these are sharks, rays. One, and you're going to get to set a dog shark after spring break. That will be on the first Monday. So if you want to not smell like a fish, then for about a week, you might want to bring a lab coat to that Monday lab afterwards. Okay, so the skin is covered by teeth-like, microscopic teeth-like structures called denticles, and it's made out of a very hard mineralized substance called amyloid. Okay, this is related to the type of minerals that we have in our teeth. Okay, but it's a little bit structurally different. So this is an apomorphy. In the males, they have, only the males, they have a particular type associated with their pelvic fins, a particular device for holding the female during copulation. So even though these are aquatic, they still have internal fertilization, and these are called pelvic claspers. And in lab, you'll be able to see them. They're associated with the pelvic fins when we get there. Now, this is not an apomorphy. It probably could have been an apomorphy if we knew something about placoderms. It might be an apomorphy for Nephrostomatum, but all we have of placoderm fossils are bones, okay? Not any part of the fleshy body. So probably all Nephrostomes originally had what's called a lateral line system. And so this is just under the skin on each side of the body, there's a long fluid-filled tube just under the epidermis that is sensitive to pressure changes. So when you compress water, it creates waves, and that creates pressure on the lateral line system. And from this, the fish can tell the direction. Even if they can't see, they can still tell the direction where the pressure is coming from. All right, so that's even other groups of fish, not just only Chondrichthyes, but others going up the phylogeny, they have a lateral line system, so it's not unique. But they have an endoskeleton of cartilage. Isn't that interesting? Because in addition to jaws down here for Nephrostomes, mineralized skeleton is also it's an apomorphy. So how do we know this? Because we have a lot of placoderm fossils that indeed they had bone. All right, so it had to have evolved before Chondrichthyes. So this is a secondary loss. And we know that also that it's a secondary loss. So I'm going to put that have it up there as an apomorphic. But you can put up here, not carboplatin skeleton, but loss of mineralization. Loss of mineralization of the skeleton. We do have some sharks that have some bones. Okay, but most of their axial skeleton, even the ones that have a little bit of bone, has been, it's just cartilage. And that's, this name was given to them, chondrichthyes, long before we understood this particular character, okay? Because what chondro means is cartilage, okay? It is a Greek word that is corresponding to soft material, connective tissue that we call cartilage. And this is from Greek. Ichthyes is from Greek, not from Latin, and that's the word for fish. So these are cartilaginous fishes. All right, so that's the historical part here. They have a two-chambered heart, so right now, not any greater specialization whatsoever. All these other fish going down have been two-chambered hearts somewhere. Well, the two chambers are called an atrium and a ventricle. And when we get into the circulatory system, we'll go into a lot of details on what these things do. All right, and as far as their ecology, some of these, most of you probably think of sharks as predators, which many of them are, but you also have some that are just suspension feeders as well. They're taking organic material out of the water. They're not predatory whatsoever. We believe that this from here on, these are marine, okay, mostly marine deposits. But from here on, and I'm not putting a name up here, probably the rest of the living gnathostomes probably evolved and originated in freshwater. There's a lot of their physiology that I'll point out later on really makes sense if they evolved in freshwater and then secondarily returned to the ocean. Okay? And that's something I'll talk about a little bit later. Also an old name. A lot of people don't like that and change this to something else. And so right now I don't know what because I find many different names for the rest of the clade. Osteichthyes, it is bony fish. Okay, ichthyes means fish. Osteo means bone. And this once again is where we have some relics of past thinking that have gone into words that we have to just retain because it's too cumbersome to keep changing words. Because it used to believe that, okay, we had two branches, chondrichthyes for sharks and rays, osteichthyes for all other fish, and then tetrapoda for land vertebrates. That's the way the classification used to be. But now that we have a phylogenetic approach, we know that tetrapods, that is terrestrial vertebrates, we know we evolved from a fish-like ancestor. Okay, so this is osteichthyes, I'm putting it with this little clay. All right, so for this group, this is the rest of the vertebrata. Of course, that's not an apomorphic. Okay, bony exoskeleton, endoskeleton. That happened way down here in the phylogeny. But believe it or not, this is also a new idea in the last studies over the last 20 years or so, is that they, from the esophagus, as alveoles of the esophagus. Okay, so from the mouth, you have the pharynx. Behind the pharynx, between the pharynx and the stomach, is a pipe called the esophagus. Off of the esophagus, there evolved these two bags that came out, and they originally were lungs. Okay, this probably occurred, during Carboniferous phase of the Paleozoic, when there's a lot of shallow seas. Fish have a bad time with respiration because in stagnant waters, oxygen is not abundant. Oxygen is not abundant at all. And so if they could supplement their oxygen supply by gulping air, and we do have fish today that do that, okay? Coming up to the surface, gulping air, because the oxygen concentration in air is much, much higher than what it is in water, especially. And another problem here too is that the oxygen content in water depends on temperature. And so if it's a warm temperature, there's very little oxygen. and furthermore, if it's stagnant, not moving, so that there's not a good amount of mixture between atmosphere and water, the oxygen content is very low. So even today, there are fish that will indeed gulp air. Now, in some of these fish, that original lungs has evolved in something called a swim bladder. Okay, so we believe that swim bladder, they're in the right place, the same place as where we have our lungs with regard to the esophagus. They're ventral, okay? And some of these still have a connection to the esophagus. Some of these swim bladders do not. And right now, those fish that have swim bladders instead of lungs, the swim bladder is for buoyancy, okay? They fill it with gas so that they don't have to continuously be swimming. That uses up energy, okay? So if they have this filled with gas, they reach a level of density in the water where they're not being pulled down by gravity, okay? So that's anthropomorphy. Two major branches, I'll stick these. So lungs, or derivatives. Up the ridge line. Okay. These are great fin fishes, and it is the most species-rich group of vertebrates. Most species-rich group of vertebrates. We have more great fin fishes groups than we have any other vertebrate. Okay, and so these are typical fish: tuna, seahorse, eels. Eels are not lampreys or hagfish. These are full-fledged fish up here. They just have that long body form. And other things like carp, tuna, all these types of fish that you think about happen to belong to this group. What is the anthropomorphy for them? Is that their fins are supported by usually cartilaginous rods that are called Lec8. Okay, so the bones, there's no bones in their fins. It's just cartilage. And what keeps these fins spread out is these cartilaginous rods that are called Lec8. Now, they're breathed by gills. Of course, this is the pharynx. Now, this I'm not putting here as an anthropomorphy. I'm just mentioning it's a structure that protects the gills. It's actually from the epidermis, another layer. It's called operculum. Whereas in the chondrichthyes, the gills are not protected by an operculum. Okay, they have just only little holes that go into the pharynx from the side that are called spiracles, just like in insects. But this here is a flap. This right here, over the gills, is an operculum. That's even better right there. So water is taken into the mouth over the gills and exits at the back of the gill chamber. And this here is what's called an operculum. Okay? But I'm not putting it as a it also serves for ventilation. It is part of the fish's ability to draw water in through the mouth and out over the gills. Ventilation means moving the medium across their respiratory surface. Okay. All right. And most of them, it's very varied. Some of them do have lungs. Most of them have swim bladders, especially the marine forms. Most of the freshwater species have neither. You know, that's been completely lost. But swim bladders are for buoyancy. Okay. The other group to which we belong is Sarcopterygiae. And we don't, as fish-formed Sarcopterygians, today we have very few. Most of them have gone extinct. But during the Mesozoic, this was a very, very big group. Or actually, Paleozoic, late Paleozoic, this was a very big group. Most of them have gone extinct. And so I'm going to put a tritome here for Sarcopterygiae. First of all, let's talk about the anthropomorphy. is instead of having cartilaginous plates, cartilaginous rods in their fins, they have bones at the base. So this here has the same bone form as we still preserve in our arms and legs, okay? And we've talked about that before. So this is for the base of both the pelvic and the pectoral limbs, which came from the pectoral and pelvic fins, okay, of sarcopterygian fishes. They have bony supports at the base that have the same pattern we have, that there's one bone, approximately 2 bones in the middle, and then a number of phalanges at the end. Okay, the number of phalanges originally in these fish is highly varied. It's not just 5. Okay, tetrapods is something like that. 3 major groups here: coelacanths. You've just known as coelacanths, but that's the name Actinista and Dipnoi, which are called lungfish. And then Tetrapoda. So I'm putting here the tritone. It is resolved. We do believe that the lungfish are more closely related to tetrapods. Okay. Coelacanths belong to a group of fishes, Paleozoic fishes, that were very, very abundant, and once thought that this group had gone completely extinct. But in the 1950s, off the coast of India, the coelacanth was captured. They're usually, these have been found in the deep ocean. We now know of 2 species, but they have lungs, okay, so and a lot of other things that are very similar. The dipnoi, lungfish, they crawl out on land. In fact, they can run around once in a while. They have fins that they can walk from one puddle to the next. Some of them have climbed trees, okay? These are all tropical. I believe there's about 7 species of them scattered through the southern hemisphere. There's a few species in South America, others in Africa and in Australia. But their lungs, they can breathe both by lungs and gills, but the circulatory system that is associated with providing oxygen supply to the blood system around the gills and lungs are very, very similar to tetrapods. So, and that's true of coelacanths as well. So there's a few of these around. But then, and of course, I've already shown this before. These are Devonian low-fin fishes, sarcopterygians, but they have the same types of bone structure that tetrapods today still conserve. So this is homologous. Don't worry about these words. That's a humerus, radius ulna, and then carpals, phalanges. And the number of phalanges that were there in these ancient fishes is varied. Some of them have as many as 9, 7, some as few as 4. But still, the bone structure of having humerus, radius, ulna, 2 in that area is preserved. So we know their ancestry. So tetrapods, these are land vertebrates, evolved from sarcopterygian fishes. Okay, so here the bone structure, of course, and the fins, they now function not as fins, but as legs. So putting them as legs is an apomorphy. And this is an early tetrapod. The bone structure up here is really of the skull. So we don't have, our mandible today in mammals is, one bone. That's not the way it is in reptiles, and it's not the way it was in early tetrapods or in these basal fish fossils, having articular and supraarticular bone, dentary. These are things you don't need to know about, but the bone and skull structure here are almost indistinguishable from Paleozoic fish. So, furthermore, if you're going to be on land, you need to have more support because you don't have the buoyancy of water. Okay? So the pelvic region of the pelvic fins, even though they're bony in ancient sarcopterygian fishes, it was not attached to the backbone. Okay, in land vertebrates it is. So that's an apomorphic fusion of pelvic girdle to the backbone to provide more support. Okay, because if you're in water, then it's not so important, but on land it is. If you remember Tiktaalik from long ago, this is a transitional fossil that preserves a lot of sarcopterygian fish-like structures, but it also has some of these derivations. It is somewhere in between tetrapods and sarcopterygian fishes. Okay, they breathe by lungs. So the adult forms. The larvae of some groups still breathe by gills. Okay, of one group. Okay, so this is Ichthyostega. It's an early tetrapod. It has also something I'm going to put up here as an apomorphy, which is in the neck. Okay, Tiktaalik, just like all other fishes, do not have a joint between the skull and the first few vertebrae. They can't move it. The vertebrae can flex a bit, but there's no articulation that we call a neck. And that's even true of Tiktaalik. It didn't have it. But of other tetrapods, the movable neck is an synapse. They all have it. Okay, so there's a lot of apomorphies here for tetrapods. Okay. All right. The only physiologically, the first groups of tetrapods, we would probably call them amphibians. But we have the same problem with the early tetrapods as we have with our stracoderms and placoderms. We have a bunch of groups down here that have all of the indicators of looking more like an amphibian, not an amniote, which is the next group. One survivor out of this, we just simply call amphibian. Most modern taxonomists, however, to distinguish it from these early amphibians, usually call this glissoamphibia. Okay, I don't care. You can have it glissoamphibia or amphibia. Okay, but they're the only survivors of these early groups. And this particular group, glissoamphibia, is monophyletic. So the groups that we have living today, that survive today, is a monophyletic lineage. This includes frogs, salamanders, have special types of teeth that is in the jaw. Mostly it's the type of articulation of the teeth to the jaw, not quite to the bone, but at least into the tissues. And you just need to know that they have late teeth. And furthermore, in the inner ear, okay, because these do have an ear, an opening for sound. Most ancestral tetrapods only have one middle ear bone. These guys have an extra one called the auricular operculum. So that's an extra bone that's in the middle ear. Okay. And of course, just like the bryophytes, as plants made the transition to land, it was not smooth sailing. They just didn't jump into terrestrial habitats. There was a gradual evolution of adaptation to terrestrial habitats. Bryophytes still have to reproduce in water. Okay, they have to have water for reproduction. That's also true of amphibians. They have to go back, even though the adults still live on land, are terrestrial, they have to go back to the water to lay their eggs. Furthermore, even the adults are still pretty much tied to moist conditions because their skin will lose a lot of water. The skin will lose a lot of water, and there's a reason for that. Okay, this would be my last slide for today. So the adults breathe with air, or with lungs. Their lungs are very, they're almost just a smooth bag. So there's not a whole lot of surface area and therefore oxygen absorption. So they also use their skin. And in fact, there's some species of tropical frogs that they have their lungs. It's exclusively their skin. And their skin is highly, highly wrinkled. They look ugly, okay? That's because the wrinkles creating a large surface area for the absorption of oxygen. So these guys use both skin and lungs. The next group that I'll bring up, Amniota, are more adapted to terrestrial habitats, and their lungs are better because they can't use their skin, okay, as respiratory organ, okay? And that's, okay. Is that all that I have up here? Yeah, okay. This is understood. Have anything? Yeah. More advanced, 3-chamber heart. They would have 2 atria and 1 ventricle. Everything, all vertebrae, all these chordates up to now have only had a 2-chamber heart. Bony endoskeleton, you know that. But the change from the tadpole form, larva, to an adult, they have to go through a complete transformation called metamorphosis. I believe that's it. Yeah. The next one, amniota.